In this video we're going to look at the display. Now you can get the display from the input output and it's called TTY. Now TTY stands for teletypewriter. What this does is it takes a number from the CPU and it will convert it into the actual ASCII character, and it will print that ASCII character on the screen. So we're going from the CPU into the display. Now let's have a look at this in a bit more detail. I have a copy of our setup here. Now before we talk through the connections, let's go in and we will have a look at an actual TTY display. So there's one there. Now the attributes, the number of rows has a maximum of 48. The number of columns has a maximum of 120. So you can see here a large TTY. We will keep the ASCII size to 8. The trigger can be rising edge or falling edge. Now we have a text colour here which we can change, and we have a background colour again which we can change. You can put a label on and it will show the label just above where the actual display is, and you can place it north, south, east and west and change the font. So that's all of the values that we're interested in within the TTY. So let's have a look at the actual input output. We're going to have the input to the TTY, which will be a number, and this number will be converted to the actual ASCII character and printed. So this is the input and it comes from the CPU. Now we have a clock here in order to clock it in, but we can't clock it in until this display clock here goes high. And we also have the reset. So that's the basics of our TTY. Let's have a look and we will see it in the top level. So you can see here in the top level we've got the value here coming into the TTY from the CPU. So this is called out1, so it's actually one of our output ports from our CPU. So here it is over here. So we have our out1, so this is coming from the CPU and it's going into the display. So we could take a value, say from a register or a memory location, and we could take it out and we point to that display, and when it points to the display it will print it, the value of the character, out on the display screen. Now we have our clock set, so this clock set here is just the same as the clock set we have for our keyboard. The reset is just the same as the reset we have for our keyboard, but we have this other thing here which is the display clock. So this is comparable to the keyboard clock here, and we will see where we generate this display clock just in a moment. So let's drop down into the CPU. Now you can see here we have our output device and it's called display. Now if we drop down into this, you'll see that we have something that was very similar to the input device. Now we've already talked through the input and output devices. So I don't want to go through in any more detail, but just quickly we can say that if the enable goes high, we know we're talking to an input-output device. And if this value here for the address goes to this value here, which is the 11, then we know we're wanting to talk to this device. Now we're going to have the data coming in. Now the data coming in is coming from the CPU. So it's coming from either a register or a memory location, and it's coming from the CPU, and it's coming out, and it goes to the output device here, and it's just sitting waiting in order to get set into this register. And you can see here it's a transparent latch here, so the enable has been set high. So as soon as this line goes high, it's going to pass the value from here across into our output, and the data out in this instance will then go as output 1 into the display, which is in the upper level. So whenever the clock gets set, it's going to pass whatever value we have here through to the output. Now the value for the display clock, we get it from the same position we get from the keyboard clock. We're going to get it at this point here, because we know that we want to pass the output from the CPU to the display whenever this line here goes high. So we can use this point here as our display clock. So if we head up to the level above, now we've talked through this circuit here before at this level, and you can see here that we have our output device, which in this case is a display. We have the output 1, so the output 1 in this case, if we head over, we should be able to see it over here. So the output 1 is here, and this output 1 heads out and goes over to the display. And you can see here at this point here it's actually 16 bits, but we're only actually using the lower 8 bits. So we have a little splitter here that splits off the top 8 bits and only passes out the lower 8 bits. Now we can also see that we're going to have the display clock. So that's the display clock I mentioned coming out here. And we have the clock set, we have our enable, which comes from the address decoder, and we have the address which comes from the address bus, and we have the ID for this device, which is a value of 3. So the actual device position for this will be FFF3. And finally we've got the reset here. So that is everything we really need to know about the display. So what we can do is we can go ahead in the next video and we will actually work through an example of displaying a value on the screen. So thank you for listening. I'll get you on the next video. Goodbye.